Hello everyone, welcome to my channel C.S.E-Pathshala. We were studying about machine learning using Python 3, and in this tutorial we will study about NumPy joining array. So if we talk about joining NumPy arrays, we can do this thing by putting contents of two or more arrays in a single array. Okay, so as we know about joining, we did this thing in SQL that we joined tables based upon keys where we used to fire a query. And whereas in NumPy, we can join arrays on the basis of axis. That means axis 1, axis 2, axis 3. With the help of this, we can join the arrays. So here we just pass a sequence of arrays and which we want to join. And we will apply concatenate function on them along with the axis by which we have to join them. So if there is no axis passed, then it has been taken as 0. Okay, so let's consider a code, then we will understand how we perform this operation. So here it is. We implement this on Jupyter Notebook. So, alright, yeah. Import NumPy as NP, ARR1 equal to np.array and ARR2 equal to np.array. That means we have taken two arrays and these are the respective elements of these arrays. Then we are performing join operation. That means ARR equal to np.concatenate. Okay, so as we know about the term concatenation, this we did in previous programming languages where we concatenate strings. So similarly, we are using a concatenate function here, and we are concatenating or joining ARR1 with ARR2. Okay, so it's a straightforward approach, and then we are printing the resultant array. So save this code. Run this code. So here it is. The concatenate array is 1, 2, 3, 4, 5, 6. That means both the array have joined. Alright. So the next thing is, if you want to join two 2D arrays along with the axis 1. Okay. So here you have been given an axis. It's mentioned here that along which you have to join the arrays. So previously there is no axis given in this example, so we just take it as 0. Okay, so let's consider this code and then understand how it works. So here it is. Import NumPy as np, ARR1 equal to np.array. That means we are taking a 2D array that is ARR1. Okay, so these are the elements. Then ARR2 equal to np.array and these are its elements. So both ARR1 and ARR2 are 2D arrays. Okay, now why we are considering it as a 2D array? Because we can see two square closing brackets. Alright, then what we are doing, we are concatenating ARR1 with ARR2. That means ARR equal to np.concatenate ARR1, ARR2, comma. We are also giving axis. Okay, so axis equal to 1. So what exactly it means if you are giving axis equal to 1, what kind of result it will generate? So let's first save this code, run this code, then we will understand what the result it has generated. Now, we have been told that to concatenate these two arrays on the behalf of axis 1. So if we talk about ARR1, if we just print this ARR1 also, let's print this, then we will understand what exactly it represents and how this operation is going on. And let's print ARR2 also, so it will be easier for us to understand. Okay, I'm just saving this code again and printing this. Okay, so this is ARR1 and this is ARR2. Now we have performed concatenate operation and the result is 1, 2, 5, 6. That means 1, 2, 5, 6. That means concatenation of this row and this row has been done. Next, the concatenation of this row and this row has been done. So this means that you have performed the concatenation along axis equal to 1. Okay, so fine. Now if you want to join arrays using stack functions, okay, previously we have seen concatenate function, and now we can also perform the join operation with the help of stacks. So what does stacking means? As we have seen this thing in data structures also. So stacking is the same as a concatenation here, and the only difference in stacking is it's done on a new axis. Okay, so obviously stack means we are just placing objects one above the other. So if there is a join, then if some of the objects or the element is present in for example 0th axis, the next element will be present on the 1th axis, that means above it. Okay, so if we need to concatenate two 1D arrays along the second axis, which would result in putting them one above the other, obviously. So this is called as stacking. We pass a sequence of array here, again similarly as we did in the previous function concatenate, okay, and which we want to join with the help of a stack method along with the axis also. Okay, so here also we supply the axis, and if there is no axis present, again we will consider it as 0. Okay, so let's consider a code first and then we will understand what exactly it do. Alright, so we are considering a code of stacking. So here it is. We need to perform stacking here. That means import NumPy as np, arr1 equal to np.array. This is your 1D array. arr2 equal to np.array. This is also your 1D array. And then we are concatenating it, joining it. That means arr equal to np.stack. Here are the arrays which we have already told we need to supply, and we are stacking it on the behalf of axis 1. Okay, so arr1, arr2, and we have been given here as axis 1. Then finally we are printing it. Okay, so let's save this code, run this code. So here it is. If I talk about axis 1, so the concatenation is done like 1, 4, 2, 5 and 3, 6. If we have been given as axis 0, okay, let's do it, axis 0. So let's save this code, run this code. So here it is. If we talk about axis 0, that means all the row something. If we just consider it as one row, if we just consider it as another row, so it's been stacked like this. Okay, and now if we talk about the axis 1, then it has been stacked like differently in a form of like a column thing. Okay, so save this code, run this code. So it's been quite visible, 1, 4, 2, 5, 3, 6. That means it's in a column format. Okay, and if you are doing axis equal to 0, that means it's in a row format. Okay, we have seen both the output. In previous example also, if you just try this thing with the concatenation, okay, just do it like this, axis equal to 0. So what's the output? Let's save this code, run this code. So here is the output, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8 and 1, 2, starting from 1, 2. That means all the rows it has been considered if we just say about axis equal to 0. But if you take axis equal to 1, it's been also considering the column thing. Save this thing, run this thing. So here it is. 1, 2, 5, 6. Okay, 1, 2, 5, 6 has been taken. Not as a column, but like this. 1, 2, 5, 6 and then 3, 4, 7, 8. Okay, fine. So this is about stack. Now in stacks we can also perform stacking along rows, NumPy provides helper function here that is called as hstack, not stack, hstack, to stack along the rows. And how it's been done, let's consider a code. So we are just implementing this code on Jupyter Notebook like this. Import NumPy as np, arr1 equal to np.array. Okay, this is your elements of array 1, arr2 equal to np.array, that means elements of array 2. Okay, both the arrays are 1D array. arr equal to np.hstack, that means we want to perform stacking along rows. Okay, we are not giving any access here, arr1 comma arr2, that's it. That means along row we need to perform the stacking, and here we are printing it. So let's save this code, run this code. So here it is. All the elements have joined along in the form of a row. So this is performed with hstack. Now if we talk about columns, yes, obviously if it can be done in rows, it can also be done in columns. So stacking along columns, if we just say, NumPy also provides a helper function here that is called as vstack. Okay, so one is a horizontal stack, one is a vertical stack. Okay, so the vstack or the vertical stack represents the column thing. So again, we just consider one more code here, and let's see how it performs stacking along columns. So okay, import NumPy as np. Again, we are taking the same array elements. Okay, and then arr equal to np.vstack arr1 comma arr2. Okay, and let's check what output is. So it's better to print output in the next line. It will be very much helpful to understand. So let's print ARR. Alright, so let's save this as the stacked array along the columns is 1, 2, 3, 4, 5. So that means we have arranged elements in the form of a column. Obviously, we have performed the stacking like this. This is your first row, and then we have put these elements on above the previous row. So something like this, it's in your output. If we talk about the column stacking, and this is how like row stacking. That means we are putting the elements side by side. Okay, this is row. This is on top. Okay. Now, if we talk about stacking along height or the depth thing, so NumPy again provides a helper function that is called as a depth stack or a D stack to perform the stacking along the height, which is same as the depth. Okay. So how it has been performed? Let's consider a code and then we will check the output. Okay. So here it is. Alright, so import NumPy as np arr1 equal to this np.array, arr2 equal to np.array. So again we are taking the same set of arrays. Then we are performing arr equal to np.dstack, and we are giving arr1 and arr2 as an arguments. Okay, and we need to perform the depth stacking. So and then we are printing the result. So let's save this code, run this code. So here it is. So it's a depth stack. That means again we have organized elements like this 1, 4, 2, 5 and 3, 6. Okay, so we are just considering these like as a column elements like 1, 4 and 2, 5 and 3, 6, and then we are performing a stacking. So it's called as a depth stack. Okay, so this is all about stacking in NumPy arrays. So we will come up with more exciting lectures. Thanks for watching. Kindly do subscribe to my channel.